Right, gonna begin by look at review a bit about graphing. So if you have functions and you can see and detect the local maximum or minimum, what would you expect to see of a graph of f prime? Yes, it's gonna be 0, and so means that you're gonna cut the x-axis, right? And if you able to determine the inflections of the functions, your f prime curve would do a U-turn at those particular x values. So how we use this to help us sketch? So here's one maximum, local minimum. So what you expect to see is that it's going to cut here the graph of f prime. It's going to cut here also. The other thing is that we realize that to the left of B, right here to the left of B, so in this area, the graph is concave, and after B is convex. So we know it must be inflection point. Expect to see a U-turn here, and this is concave or convex. I'm sorry. Here you see this is concave, here convex. So there's a the C point is inflection point, and not only that, because it's given here at point C, the tangent is horizontal. So C is horizontal. It's a horizontal inflection, and it means that it's dy dx is 0, right? It's horizontal inflection means it's dy dx is 0, and so when you sketch f prime, is going to cut here. So rather maybe touches, because it's gonna do U-turn, and here's the inflection. So I'm going to U-turn somewhere. I'll change the color a bit. Look at the pen on, and so to the left of A, the slope is positive. To the right of A until E is all negative. Slope all negative. You see it's sloping down with this. All negative. You sketch, draw tangent, and here after to the right of E, the slopes are positive, as you can see here, all positive. So when you sketch it, right? When you sketch it, you're going to see this. Let me use a different color, maybe purple, right? So I'm gonna go down because it's gonna go stay positive. This is an f prime graph. So here, cut. There's a U-turn. It needs to do a U-turn. A U-turn here because, and at the x-axis because it needs to be 0. Down, U-turn here, and then go back up all the way, because after the point E to the right, the slope of a tangent here, all this is positive. So this is a f prime graph, right? Isn't it very straightforward? And then you answer state the point where f prime f is 0, f prime is negative also. And so we're talking about this area here, and we're talking about the graph of this area of the fx, right, below the x-axis, and also we're talking about where the f prime graph is also below the x-axis and cannot be equal. So point C is out because point C is on the x-axis. There's only one such point, and that point is D. So to answer part 1b, that point is D, because only D behaves like this. At D, you find that fx is negative, and the value of f prime is negative also. And the part 2, state the points where f prime is equal to 0 and f double prime is equal to 0. Wow, there's only one such point. When you have f prime equal to 0, f double prime equal to 0, that means we're looking for, yes, a horizontal inflection. This is basically a horizontal inflection point. Definitely satisfy these two properties, inflection points, and that means that point is C, as you can see here, right here. Okay, so I hope you try this again, and all the best.